Welcome to this EWRB Electrical Service Technician Training course. I'm Aria, an electrical tutor working with Whitroy. In this course, I'll guide you through all the topics covered in the EWRB Electrical Service Technician Exam Teaching Guidelines. Welcome back. Today we'll look at Topic 8.9, Systems of Supply, which explains how electricity is generated, transmitted, and distributed across New Zealand. By the end of this lesson, you'll understand where our electrical energy comes from, how it reaches consumers, and why we use a three-phase, four-wire system. Let's start with Topic A, the New Zealand Electrical Supply System. Topic A, the New Zealand Electrical Supply System. Electricity in New Zealand starts at generation, where power stations convert energy from natural sources such as water, wind, geothermal heat, or gas into electrical energy. 1. Generation. Electricity is generated at around 11 kilovolts, kV, in large power stations such as hydro or geothermal plants. 2. Transmission. From there, it enters the national grid, which uses very high voltages to move electricity efficiently over long distances. The transmission system operates mainly at 220 kV and 110 kV, carried by large pylons and transmission lines owned by Transpower. 3. Distribution. Electricity then passes to local network companies, where the voltage is stepped down for regional distribution. The most common distribution voltages are 33 kV, 11 kV, and finally 400-230 volts for consumers. In summary, electricity flows from generation, transmission, distribution, consumer, with voltage reduced in stages to make it safe and usable. Topic B, typical voltages in each part of the system. Let's look at some typical voltage levels used in each stage of supply. Generation, 11 kV at the power station alternators. Transmission, 220 kV or 110 kV across the national grid. Sub-transmission, 33 kV between regional substations. Distribution, 11 kV to local street transformers. Consumer supply, 400 volts between phases and 230 volts from phase to neutral for single-phase consumers. So, when you plug in a 230-volt appliance, that energy may have started as 220,000 volts at the power station, safely reduced through transformers. Topic C, the three-phase four-wire distribution system. Now let's move to Topic C, the New Zealand three-phase four-wire distribution system. The standard system in New Zealand is a three-phase, four-wire system that supplies power to different types of consumers. 1. Three-phase consumers. These are typically commercial or industrial sites with heavy loads such as motors or machinery. They use all three active conductors, L1, L2, and L3, plus a neutral. The voltage between any two phases is 400 volts, and each phase to neutral is 230 volts. 2. Two-phase consumers, less common today, but sometimes used for medium-sized loads. They use any two of the three phases, giving a line-to-line voltage of 400 volts. 3. Single-phase consumers. Most homes and small businesses use single-phase supply, taking one phase in the neutral, giving 230 volts. Each of these supplies comes from the same three-phase transformer, which is star-connected on the secondary side with the neutral earthed through the main system. Topic D, advantages of balancing the load over three phases. Now let's finish with Topic D, the advantages of balancing the load over the three phases. Balancing the load simply means spreading the current evenly across all three phases. This is important because it 1. Reduces neutral current. If the loads are balanced, the currents in the three phases cancel in the neutral, reducing neutral heating. 2. Improves efficiency. The system operates more efficiently with less voltage drop and energy loss. 3. Prevents overload. Balancing helps prevent one phase from carrying too much current, which could trip breakers or blow fuses. 4. Improves voltage stability. Balanced loads keep voltage levels steady across the network. So, in spoken summary, when each phase carries a similar load, the system runs cooler, safer, and more efficiently. Summary. Let's recap topic 8.9, Systems of Supply. We learned that electricity is generated at about 11 kilovolts, transmitted at 220 or 110 kilovolts, distributed at 33 and 11 kilovolts, and delivered to consumers at 400-230 volts. The New Zealand system uses a three-phase, four-wire arrangement to supply single-phase, two-phase, and three-phase consumers. Balancing the load across phases improves efficiency, reduces losses, and keeps the system stable. That's the end of topic 8.9, Systems of Supply. In our next lesson, we'll move on to topic 8.10, Multiple Earth Neutral System, where we'll see how earthing and bonding keep these supply systems electrically safe for everyone.